Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is Morgan's law on set theory. In mathematical statistics and probability, it is important to be familiar with set theory. The elementary operations of set theory have connections with certain rules in the calculation of probabilities too. The interactions of these elementary sets, operations like union, intersection, and the complement, are explained by two statements that are known as De Morgan's law. After stating these laws, we can see how to prove them too. Here is the statement of De Morgan's law. For every pairs of sets A and B, first law states that A union B complement equal to A complement intersection B complement, and the second law states that A intersection B complement is equal to A complement union B complement. We all know that De Morgan's law relate to the interaction of the union, intersection and complement. So let me recall few points about the operations like union, intersection and complement. Let us start with the intersection. The intersection of the sets A and B consists of all the elements that are common to both A and B. The intersection is denoted by this symbol, the inverted U-like shape. Okay. Next one is union. The union of the sets A and B consists of all the elements that are either A or B. It includes the elements in both the sets. The intersection is denoted by this symbol, A union B. Third operation is complement. The complement of the set A consists of all the elements that are not elements of the set A. This complement is denoted by C-like symbol, which is written just right above the set name. Now that we have recalled these elementary operations and also we have stated De Morgan's law, and now let us discuss the proof of the laws. Let me start with this law. Before jumping into the proof, we will think about how to prove the statements that are stated. We are trying to demonstrate that two sets are equal to one another. The way that this is done in a mathematical proof is by the procedure of the double inclusion. Okay, let me give you the outline of this method of proof. Here is the outline. Show that the set on the left side of our equal sign is a subset of the set on the right. That should be our first step. And then we have to repeat the process in the opposite direction, and we have to show that the set on the right is a subset of the set on the left. So these two steps allows us to say that the sets are in fact equal to one another. They consist of all of the same elements. Okay, so this is the outline for the proof strategy. Now let us see the proof of one of the laws. As I said earlier, I am going to prove this using the procedure of double inclusion. So we will see how to prove the De Morgan law. A intersection B the whole complement equal to A complement union B complement. First, suppose that X is an element of A intersection B the whole complement. We are just assuming some element from this set. So this means that X is not an element of the set A intersection B. Am I right? Okay. Since the intersection is the set of all elements common to both A and B, intersection means common. So the previous step means X cannot be an element of both A and B. Am I right? So this means that X must be an element of at least one of the sets A complement or B complement. So we are going to use the definition. By definition, this means that X is an element of A complement union B complement. Hope you are clear with one half of the proof. We have shown that the desired subset inclusion. So our proof is now halfway done. So to complete this proof, we show the opposite subset inclusion. We have proved left to right. We are going to prove right to left. More specifically, we must show that A complement union B complement is a subset of A intersection B the whole complement. So we are going to begin with the same thing as we did in the previous half. So let us begin with an element X. X be any element in the set A complement union B complement. We are going to start from the right side. We are assuming some element from the set on the right side. This means that X is an element of either A complement or that X is an element of B complement. Am I right? Thus, X is not an element of at least one of the sets A or B. So that is the meaning of the complement. So X cannot be an element of both the sets A and B. This means that X is an element of the complement of the intersection of both the sets. Am I right? So we have shown the desired subset inclusion. Proof of the De Morgan's law is very simple. You should know the meaning of the operations like intersection, complement and union. Hope you're clear with the proof of the De Morgan's law intersection. Okay. The proof of the other statement is very similar to the same proof that we have outlined just now. So all that must be done is to show a subset inclusion of sets on both the sides of the equal signs. The complement of the union of two sets is equal to intersection of their complements, and the complement of the intersection of two sets is equal to union of their complements. These are called the De Morgan's law. You can name this like this is called De Morgan's law of intersection, and the previous law is called De Morgan's law of union. Let us now see the proof of union. You can either use C to denote complement or dash to denote complement. Okay, here is the proof for the first law. Let P equal to the left side of the equation A union B the whole complement, and Q equal to the right side of the equation A complement intersection B complement. We can take an arbitrary element of P. Let X be that arbitrary element of P, then X belongs to the set P. It means X belongs to A union B the whole complement. Am I right? It means if X is an element of A union B complement, then X does not belong to A union B. Am I right? Then X does not belong to either of the set A or B. If X does not belong to the set A, does not belongs to the set B, it means X belongs to the set A complement and X belongs to the set B complement. Hope you're clear so far? So you can combine these two results and you can say that X belongs to the set A complement intersection B complement. That is nothing but X belongs to Q, A complement intersection B complement. Therefore you can say that P is contained in Q. Let that be equation number 1. Again, let Y be an arbitrary element of Q. We are going to prove the other side of the proof. Then Y belong to Q, which implies that Q is nothing but the right side. A complement intersection B complement. So if you look at this in detail, you can say that Y belong to either A complement or B complement. Or you can say Y belongs to A complement and Y belong to B complement. If an element belongs to the complement, it means that it does not belong to the set. So you can say that Y is not an element of the set A and Y is not an element of the set B, which is nothing but Y is not an element of A union B. If Y is not an element of A union B, you can say that Y belongs to the set A union B complement, which means Y belongs to P. So you can say that Q is contained in B, P. Let this be equation number 2. Now combine equation number 1 and 2 so that you will get the result P is equal to Q. Both are equal. Hence we have proved the De Morgan union law. A union B complement is equal to A complement intersection B complement. These two statements can be illustrated by the use of Venn diagrams. You can demonstrate by using an example. So in order to demonstrate that these statements are true, we must prove them by using definitions of set theory operations like we did in this video. Hope you're clear with the De Morgan's law on set theory. In case if you have any query regarding this video, kindly let me know. See you in the next video. Have a great time ahead. Thanks for